It is just after 6 in the morning on the uplands of Exmoor in southwest England. And Dr. Nikki Green is standing knee-deep in a stream the color of cold tea. Mist lifts off the water in slow ribbons, blurring the line between the bank and the gray sky above it. She reaches into the current, closes her fingers around the wet mesh of a cylindrical trap, and lifts. Inside, a handful of heavy-clawed crustaceans click against the plastic, their mottled shells dark and slick in the early light. The trap is full. And that is the problem. Because beneath her boots, hidden in the gravel she is standing on, are thousands of animals the trap will never touch. For more than a decade, across an entire continent, people have pulled traps exactly like this one out of the water and counted each catch as a victory. They were counting the wrong thing, and the animal in her hand was never the one that mattered. For decades, European agencies have waged a quiet, expensive war against a single invader, the North American signal crayfish. It is an adversary that physically rebuilds the world it enters, tunneling into riverbanks until they collapse, and carrying a disease that kills native crayfish at a rate approaching 100%. To fight it, people deployed an army of plastic and steel and spent enormous sums on labor, traps, and monitoring, all built on a single assumption: remove the largest, most formidable adults, and you break the spine of the invasion. That assumption was not just wrong, it was backwards. The trapping did something no one intended. It became a selection pressure, quietly stripping out the very adults that were holding the population in check and leaving a hidden factory of juveniles free to explode. And the thing that finally slowed these waterways down would not be human at all. It would arrive on its own, without funding, without permission, from predators that had been in these rivers the entire time. But to understand how a trap became the invader's ally, you have to go back to 1960. The story begins in Sweden. For centuries, native crayfish had been a prized part of Scandinavian food and culture, the centerpiece of late summer feasts, until crayfish plague swept through and emptied the fisheries. That plague was not new to Europe. It had been chewing through native populations since around 1907, arriving with imported American stock and spreading river by river. By mid-century, looking for a hardy replacement, authorities looked west, across the Atlantic, to the rivers of the Pacific Northwest and the Columbia River Basin, where a larger, faster-growing crayfish lived. Passifasticus leniusculus, the signal crayfish, named for the pale signal flag patch at the hinge of its claw. Crucially, it shrugged off the very plague that had devastated Europe's native stocks. Around 1960, the first introductions arrived in Sweden. The logic was purely practical: swap in a tougher animal and rescue the industry. But nobody at the time fully understood that the new arrival was not merely resistant to the plague. It was a carrier of it, healthy and infectious at the same time. By the mid-1970s, the practice had crossed to Great Britain, where signal crayfish were brought in for farming despite explicit warnings from biologists about competition and disease. Escape was never a question of if. Within a few years, the crayfish had slipped their ponds and entered the open arteries of Britain's rivers, and today they are established across the mainland as far north as the Moray Firth in Scotland. What followed was swift, and it was devastating. No mechanical trap stopped them. No chemical treatment cleared them. No bounty broke them. Governments and river trusts threw everything they had at the problem. In small, enclosed water bodies, biologists tried aggressive biocides and found they could indeed wipe out a local population, but only by sterilizing everything else in the water alongside it, every insect, every snail, every fish, which made the method useless for any open, flowing river. So the effort shifted to traps and to hands. Money went into manufacturing standardized baited traps, into licenses, into training and deploying thousands of volunteers to clear rivers stretch by stretch. It felt like progress. Buckets filled, tallies climbed, and still the distribution maps kept turning red, one catchment bleeding into the next. The invasion did not slow, it accelerated. And for years, everyone told themselves the same comforting story: that this was simply a problem of scale. Trap harder, catch more, eat more of them, do enough of it, and the population would collapse. Then researchers actually counted. In a heavily invaded upland stream in North Yorkshire, scientists from King's College London and University College London ran a meticulous census of the entire crayfish population, not just the animals big enough to enter a trap, but every single individual, down to the ones smaller than a 1-pence coin. To do it, they could not rely on traps, because relying on traps was the exact error they were testing. Instead, they used a technique that drains a short section of stream in a slow, controlled way 3 times over, so that nothing can hide in the gravel or the undercut of the bank. Only then can you actually see what a riverbed contains, and what it contained was staggering. In places, the crayfish were packed at densities approaching 110 animals per square meter, far beyond anything trap surveys had ever suggested, but the number that rewrote the entire management model was smaller. Of the tens of thousands of crayfish in that stream, only 2.3% were large enough to be caught in a standard trap. 2.3%. The other 97.7% were juveniles, sitting in the gravel, completely untouchable by every trap in the country. Now the mechanism clicks into place. Large signal crayfish are cannibals. Left alone, the big adults hunt and eat the small ones, and that cannibalism is the single biggest brake on the population. So when trapping strips out those large adults, it does not starve the invasion, it releases it. The juveniles that would have been eaten now survive in unprecedented numbers and rush to fill the gap, maturing fast, breeding early, often reaching breeding age before they are ever big enough to be caught in the first place. The trap was not removing the population. It was removing the population's main predator, which happened to be itself. And the same research showed that the popular idea of eating our way out of the problem made everything worse, because a market for wild signal crayfish gives people a reason to move them into clean water to start new harvests. And every one of those moves risks seeding a fresh invasion or accidentally killing the last rare native crayfish by mistake. If the hidden logic of how ecosystems correct themselves is the kind of thing you find fascinating, you might consider subscribing. It is most of what we do here. To see why this animal is so hard to stop, look closely at how it is built. Paciphasticus leniosculus is armored like a small tank. In Britain's rich waters, an adult can reach 16 to 18 centimeters and live up to around 20 years, which is remarkable for a freshwater crustacean. A single mature female can carry a few hundred fertilized eggs beneath her abdomen, cradling them through the whole winter until they hatch in spring, and unlike many aquatic animals, she guards the hatchlings for a time rather than casting them adrift. Set against Britain's native white-clawed crayfish, Ostropodimobius palipes, the signal matures earlier, grows faster, and within a few years is simply bigger, muscling the smaller native animal out of the crevices and undercut rocks it needs to hide in. The native is not outcompeted in some abstract sense. It is physically shouldered out of its own shelter, left exposed to the current and to anything that hunts. But size is only half the weapon. The other half is microscopic. Signal crayfish are chronic carriers of Aphanomyces astazzi, an oomycete, a kind of water mold known as crayfish plague. The signal has an immune response that walls the infection off and holds it at bay. The white-clawed crayfish has no such defense, none, because it never evolved alongside the disease. And when the plague reaches a native population, the death rate approaches total. It does not thin the population, it erases it, and it leaves the river clean and empty for the invader to occupy. Once established, the crayfish begins to remodel the river itself. The Canal and River Trust has documented signal crayfish driving burrows as much as 2 meters deep into soft banks and packing them in at tens of tunnels per square meter of bankside. Pack enough of those into one stretch, and the earth effectively liquefies from within. Banks retreat, with some studies measuring accelerations in bank collapse well over 200% compared with unburrowed banks. The water turns permanently cloudy with suspended sediment that smothers fish eggs and gravel-spawning beds. And old canal walls, some of them 2 centuries old, give way. All of that loosened earth becomes sediment moving downstream, tons of it per kilometer every year, silting up the river far below. And below the waterline, the animal's appetite does the rest, stripping out the insects and snails and submerged plants that everything else depends on, pulling the base out from under the whole food web. This is the invader at full strength. And it is exactly here, where millions in engineering and labor had failed, that something else began, quietly, with no press release and no budget line. Biologists watching predator and prey in these waters noticed an odd thing. In certain lakes and streams, despite the signal crayfish being present and even abundant, the population simply was not exploding. It was being pinned down. The mechanism turns out to be almost embarrassingly simple, and it comes down to which predators are present and how the habitat is shaped. In lakes, the enforcer is the large native perch, Perca fluviatilis, a stout, striped ambush predator that grows big enough to take a crayfish whole. Where big perch are abundant, crayfish are suppressed, and the coupling is tight. More perch biomass in the water, fewer crayfish on the bottom. In flowing streams, the pressure comes as a pincer, from two directions at once, from native eels, anguilla, working from below, and gray herons, Ardea cinerea, working from above. And this is the part that matters most. These predators go after exactly the life stage the traps miss. Eels are long and muscular and boneless enough to push right into the crevices and burrows and pull out the juveniles that thought they were safe from the outside world. Herons stalk the shallow riffles at dawn and dusk, spearing the young crayfish forced out into open water to feed. Where human trapping had accidentally protected the juveniles by removing their cannibal parents, the predators do the opposite. They hunt the juveniles directly and relentlessly in a way no trapping program ever could. This is not a story about a miracle cure. Nothing here wiped the signal crayfish off the map, and nothing was going to. What the predators did was something more useful and more real than eradication. They established containment. They turned certain stretches of water into zones where the invasion was held to a slow, grinding stalemate instead of a runaway boom, and they did it for free, continuously. On a schedule no funding cycle could ever match, which forces an uncomfortable question about all that money. For decades, public funds were spent on the belief that enough cash could simply buy a victory. But there was never a single clean bill for it, only a recurring cost that never ended. The labor of setting and emptying traps season after season, the heavy machinery to shore up collapsing banks, the permits and surveys for every stretch of riverworks, the endless monitoring, the biocide trials that bought a few months of relief and never a cure. It was rent, not purchase. And once you accept that native predators can hold the line locally, the whole economics inverts. Protecting predatory fish, restoring the wetlands and reed margins that feed herons, keeping the fallen wood and undercut banks that shelter eels and juvenile fish alike, all of it starts to look far cheaper and far more durable than another decade of plastic traps that were feeding the problem the whole time. And this pattern is not unique to a crayfish or a country. It shows up wherever people try to outmuscle a living system. Australia introduced the cane toad as a control and got a self-sustaining plague it could neither trap nor poison out of existence. North America met the zebra mussel with scrapers and screens and chemical treatments and still fell hopelessly behind an animal that spawns by the million. In the Florida Everglades, teams have spent years hunting down the Burmese python across terrain too vast for any search to truly cover. And for every snake they pull out, the swamp hides an unknown number more. The lesson underneath all of them is the same. An ecosystem is not a machine where you can pull one part out or bolt a new one on and leave the rest unchanged. Remove the cannibal and you free the juveniles. Every intervention moves through the entire web in directions we rarely predict, and natural selection keeps working quietly the whole time, faster than any policy can be written to catch it. It is now just after 6 in the evening on Exmoor. The morning mist has burned off into a low amber sun, throwing long shadows across the stream. Dr. Nikki Green lifts the last trap of the day and tips the adult crayfish into a bin. She rinses her boots in the clear current, and as she does, she watches a small native brown trout slide beneath a stone, and on the far bank, a gray heron standing utterly motionless, waiting. The same trap that started her morning is empty in her hand now, and it means the opposite of what she once believed it did. We cannot trap our way out of the mistakes that put these animals here. The signal crayfish is not leaving. But if we step back and let the river rebuild the food web it already knows how to build, the water may settle into a balance that no amount of money could ever have bought. So here is the real question. Should we stop funding trapping altogether and pour those millions into predator and habitat restoration instead? Or does careful hand removal still earn its place guarding the last strongholds of the native crayfish?